Hello, everyone. Thank you for joining us for today. My name is Alexandra. I'm working at DataArt as a PR, and today I am going to be a moderator of our event. And before we start, I would like to inform you that you could ask our speakers questions during the presentation in YouTube chat. And after each speech, we will have time to discuss all of them. Don't be shy and ask as many as you want. And one more thing, I would like to ask you that to fill an online form, we have below our feedback form. It is very important for us. Please fill in after the event. And okay, let us begin. Today we are going to have two presentations. And as a first speaker, I would like to invite Vyacheslav Shevchenko. The stage is yours. You are welcome and enjoy the presentation.
Yeah, hello everyone. Give me a few seconds just to share my screen. Okay, so I hope that you're already able to see it. My name is Vyacheslav, and today I'm going to talk about GraphQL, its necessity and common problems that you may face if you decide to use it in your project. So, in general, I was using Apollo GraphQL every day for more than 1 year. We created a project from scratch using it, and I collected some common issues to discuss today. As a small addition, I'm not going to belittle the advantages of GraphQL. I just want to give you some hints when it makes sense to use it and when it's an overkill. In this presentation, I don't have an aim to present how to build an Apollo GraphQL application from scratch. I assume that you have some basic knowledge of GraphQL, but to be sure that we are on the same page, I will make a short comparison between GraphQL and REST approaches. As you know, in REST, we have to send a request to the particular endpoint with targeting specific URL, headers, request body, and so on. In response, you will get data according to the settings of your server and configuration of your requests. In the most popular situation, you need to get a JSON. Pretty often, one API will be used by different applications. For instance, you may have web and mobile applications that are supposed to use the same API. Like a consequence, for some receivers, we may get an overloaded answers from the API. Some of the fields may be essential for the mobile application, but not for the web. But in result, you will see all data despite the fact that you need only part of them. This issue can resolve the GraphQL approach by introducing one more layer in the application between the endpoint that you need to ask for data and your particular UI, mobile or another requester of data. With GraphQL approach, we will write our own server that will serve GraphQL route and expects everyone to send requests there. Basically, there are two ways how to send GraphQL request. You can make it via GET request. In order to do it, you just need to specify query parameter with some request, as you can see here on the slide, the first one. And the second option, we can do it via POST request, and it's more desirable to do. You need to specify operation name, its query name, some optional variables, and query. So that query will be generated automatically when you use GraphQL engine. With such an approach, your GraphQL server will return you only those fields that you have requested before. Thanks to it, you can have only one endpoint with one described schema for several applications, and each application will be able to get only those data that are essential. For making some changes as replacement of put-post methods in REST API approach, GraphQL provides mutations that you may use. The mechanism is pretty the same. You have to send some data according to the scheme and get requested fields from the response. As you can see, it allows us to decrease the amount of code and headache that you may have by writing several handlers for different applications for same route, but also it brings some additional challenges that we are going to cover in this presentation. Let's go into some details and speak about possible drawbacks of GraphQL. Here you can see an example how to add GraphQL route for your Express application in Node.js. If you're familiar with Express, it will be pretty straightforward for you. In this particular example, I've added a bunch of middlewares for the GraphQL route. You can see it here. When a request comes to the server, and sequence of custom middlewares will be executed. For my situation, I need to apply some course settings for this request, make validation if that request is authorized by checking token in headers. Then I add GraphQL Upload Express middleware that will be described in a few moments later. And finally, I assign to this route GraphQL HTTP function from library that create an instance of GraphQL. As I mentioned before, we have to define a scheme for making predictable queries and mutations. In this example, I added a possibility to make multiple file uploading, and you can observe it in my scheme as upload is defined here as an array. Okay. But also, we need to add resolvers for them, and in this example, they are defined right here, query and mutations. And we need to define GraphQL upload from GraphQL upload package. For instance, we had to add additional library that I mentioned, GraphQL upload. And after defining it here into the scheme, we'll be able to make mutations with some file. Right now, I'm using mutation that is called multiple upload and assign a handler for it that is going to be upload such files to any file system that you want. Okay. So, by the way, there is a built-in possibility of the file uploading without any additional libraries, but it's going to be removed soon. According to the documentation, it does not support the new Node.js version. So, if you want to have an up-to-date solution, please use the GraphQL upload library. But what about file downloading? If the user wants to download some files via making request, there is a bad news. It's not possible in GraphQL. But of course, there are some workarounds. In my project, we had to add a separate endpoint to use Express server that is not managed by GraphQL and work with file downloading directly without any Apollo or GraphQL tools. So no rocket science here. You can just Google any Express example how to make file downloading and implement it here. From the UI side, you would have to make a regular REST request for downloading that file. Another challenge is using the SSR approach with Apollo. For instance, I was using Next.js together with Apollo, and one of the things that you should keep in mind is SSR hydration for your data that was requested during the server-side rendering. Right now, you can see the common approach on how to organize such a request. In this example, we create a separate Apollo client instance per server-side request, right here. And when the application is already rendered, we would like to have one instance of Apollo client and reuse it every time when a new request must be called. Create function returns an initialized Apollo client instance. Then, thanks to SSR mode, we will have access to the getDataFromTree function that walks down the entire tree and executes every required query that was found. This is an example of Next.js. Here we are making a request from GraphQL during the server-side rendering. Answers are going to be stored in cache, and we will be able to extract the data and pass it down to the components. Please do not forget that we need to make SSR hydration for that data, but this topic is out of scope of this presentation. You can check how to do it in the documentation of the library that you're going to use for SSR. It can be Next.js or whatever you want. As for state management, there are some tricks in Apollo. If you want to manage your state in the same way as you work with queries and mutations, you would need to define the similar local query in GPL format, but put the definition into the type devs during the Apollo initialization, and then you should write such a request and use it in the query component from the Apollo library. Also, it is possible to make direct read and write operations based on the defined request from the client cache. But here you may have some issues. Sometimes, I'm not sure why, if you try to read local data directly from the cache without a query wrapper, you may get all data that was there before local state mutation. Here I have access to the client variable thanks to this Apollo high order function. Also, it is accessible via hooks in newer version. So in this example, I just read data thanks to that client variable, and then I can put it down to another component. Okay, so you might get all data that was there before local state mutation. And one more thing that you need to keep in mind that if you use local state in your cache, you need to prefill it with some default data after Apollo initialization. If you don't do it, it may cause some issues in your application when you will be trying to get local data that does not exist in the cache. So it's more safe to use query wrapper, like here, if you want to be sure that you have consistent data. The last modern feature of Apollo for local state management is reactive variables. They are a bit similar to the Mobix way of coding. You have to define such a variable, and after mutation, the value of a reactive variable. All queries that depend on the variable refresh, and your application's UI updates accordingly. Such variables are stored outside of Apollo cache. You can use reactive var hook provided by Apollo for getting access to the local values. As a possible drawback, you will have to deal with several sources of truth of your application state, and one is from the Apollo cache, and the second one is reactive variables that may be challenging. The next important topic is error handling for your GraphQL requests. In order to build proper error handling, we need to implement it on both sides, front-end and back-end. So let's take a look at the UI implementation. We may have two types of errors. First type is network error, when Apollo server is unavailable or user is not authorized to send a request to the GraphQL endpoint, and you can see such kind of errors here. And the second type is GraphQL error, when something throws it into your Apollo resolver. You can see it here. And we need to create a proper handler for both of those types. In the example, you can see how we can differentiate those types, but it's up to you how you are going to resolve it. You may display some pop-up models, notifications, or even create a queue for storing errors, which are going to be displayed one by one. For instance, you can hit rate such errors if you use SSR approach and pass it to the UI side and then display when your application is going to be ready. You may notice a pretty strange piece of code here. Its response errors equal null. It allows us to clear the error stack in the Apollo memory. If you have an SSR application, some errors may occur during the server-side rendering. And if you do not clear the error stack, they will break your application when it's going to be rendered on the client side. So in this case, you need to create another solution for how you're going to handle such types of errors on the server side. So let's move on to the backend side. It's a pretty similar piece of code that I showed to you for the upload example. We need to define our GraphQL endpoint with all middlewares that you want to use, and finally, get internal middleware by GraphQL HTTP function. In my example, there is a get GraphQL setting function that is returning an object with all needed configuration. What you need to pay attention to is a custom format error function. This function allows us to intercept all GraphQL errors and make a unified handler for them. For instance, you can return an error message and custom error that you can form in the way you want, and after it, you will be able to get an access to that data on the UI side. So as you can see here, custom errors are placed here, and it will be accessible on the UI side when you send it from the GraphQL side. Finally, let's imagine such an application that you may have. If you have an application with Redux, Mobix, or another state management system in place, your application needs SSR and you use Next.js for it or another solution. You have to upload and download a lot of files, and you have only one endpoint to communicate with. In such a case, probably using the Apollo GraphQL solution is not the best approach, as almost all advantages of GraphQL will not be applicable for you. You already have a state management system, so you don't need Apollo state management. You have to download a lot of files that is not supported by GraphQL. You have to deal with SSR hydration with Apollo, and moreover, using only one endpoint with Apollo forces you to write a lot of additional code base without strong benefits. The only one pros that I can see here is that you are able to define a scheme for your requests and ask only those fields that you need. Another architecture that you may have is you were asked to build an application from scratch. In the requirements, you can see that your application has to communicate with different API, probably using token authentication on each of them. So you need to manage those tokens in one place somehow. Data from that API must be aggregated somehow and reused by your system together. You don't have to implement an SSR solution, or it's fine for you to deal with it. As this is an application that you build from scratch, you can decide to put a state into the Apollo state management. I'm talking about local state. You may have WebSockets that can also be handled by Apollo in a straightforward way by Apollo subscription. In the requirement, you may see that a lot of different clients, such as mobile applications, web, or another API, are gonna use your application. In this example, using Apollo GraphQL may be really helpful, as you will be able to manage different endpoints under the hood. And you will be able to scale your application easier if you are going to be asked to add one more endpoint for communication. Also, you can split, for example, your team into two teams. One of part of that team is going to be focused on the UI, and the second one is going to be focused on GraphQL side. So I hope that I described different scenarios of building your application and possible challenges that you might face during the integration of Apollo GraphQL. If you have any questions, please go ahead. I will be happy to answer them.
Okay, thank you, Vyacheslav, for great speech. And as I saw, we have no questions, but don't worry, you can ask after our event and we will answer directly in the comments. Okay, wait a second, but no any questions. Thank you, Vyacheslav, one more time, and not to prolong, I think we can proceed our IT talk, and I would like to welcome our next speaker, Maciej Sikora. Are you ready?
Yeah, ready.
And okay, enjoy the next presentation.
Hello, everybody. My name is Maciej. I will have a presentation about TypeScript and Elm language. I hope you see my screen, and if so, the presentation will be a little bit different than the typical one because the presentation will be in the text editor, and I will compare two languages. So on the left you see TypeScript, and on the right you see Elm language. And the first question which can be about that is why Elm? Because TypeScript is quite a standard currently in the front end, but Elm is still like something, let's say, used by not many people. And this is because I had the occasion to work with Elm for like more than half of the year, and this is not an ideal language, let's say, but it has some features and, let's say, syntax which is really nice. And one of those features is like pattern matching, which this presentation is really about. And this presentation is really about like emulation of the pattern matching from Elm to TypeScript. So on the left also you can see like the icons. So TypeScript will be a dog which will be running for the rabbit which will be on the right side as Elm. So let's proceed. So the bunny is running, and we'll see where. So the first example shows this is the Elm code, and this is like an action type defined here, and action is like a union of two possible options. It's a run or sleep. And we have like a simple function which from such an action creates a string. And we use here like pattern matching available in Elm. And this pattern matching is in form of case of expression. So we say case action of, and we need to define all possible actions here. Because if we don't, Elm compiler will tell us that this is an error. So this kind of expression protects us from every error related to missing something or like typing something wrong, because we need to have all possible options here covered. So how we can replicate that in TypeScript? So the first example is about using enum, which is available for TypeScript, and enum has we can define multiple options in enum, and this is like replication of the right side action. So you have run and sleep, and in terms of how we can replicate the case of, we can use a switch statement. And this looks quite similar. So we have a switch by action, and in case of run, we say running, and in case of sleep, we return Z. So this looks quite similar. As you can see, this blue text is showing how runtime how in runtime this function will behave. So for run, it's running. For sleep, it's Z. So it's quite working well. The issue is here that for Elm, if I would remove the option, it would be like compiler error. For TypeScript example, it doesn't apply. So if I do like that, I have undefined, and this is probably an error in our application. And like TypeScript is fine with that, and it doesn't compile that it doesn't complain, sorry, for that we have missing an option. So that's not, let's say, equal to the right solution. Let's try to make something different. So in TypeScript, we can also emulate the right side union by literal union, which is available here, and we can say that action is or run or sleep, and we can emulate the function exactly in the same way. So we can say switch by action, and is this run or sleep? And we can see that, for example, if I do like that, so TypeScript knows that this is wrong because action cannot be in that form. But still, if I will, so now it works, but if I will remove one option from here, like that, this will have undefined and still doesn't protect us. Let's run further, but yeah, so the bunny will show us the next example. So let's scroll here, and the next example is more complicated because the action in Elm can have an argument. So the run have additional integer argument. So our type is like nested. Let's say we have run and we have additional argument which you need to provide. And in Elm, it looks like the same as the previous example because we can use this argument directly. So this is kind of the structuring in line, let's say. So we say run, and we say that this argument, and we can use this argument on the right side. So nothing really changes, but for TypeScript, this change is like a big one because the enum in TypeScript doesn't have a possibility to have an argument at all. So this doesn't work for us. Let's see what can work for us. We can try the OP way. So we can create the classes. Let's create a class action and create a run, which will extend action, which has a constructor which defines the distance, which is a number, and we create the sleep, which is just empty, let's say, class which extends action. And now we can create a toString function which takes such action and checks if action is instance of run, then we show that, and if it's instance of sleep, then we show that. Everything works, but amount of code on the left side is like quite different from the right side, and it's quite more complicated on the right side. Yeah, and I don't think we can be happy from this solution because if I set OOP and we use instance of, this is kind of against OOP. So to be honest, let's show like how the OOP really would look like. So in real OOP, we would do that differently. I mean, we would do the action which had an abstract toString, and we would force the extending classes to implement toString. So we have toString in run, which is that, and we have toString in sleep, which is that. And our final function is just calling action toString because it's a polymorphism. And this is really how we should model that in classes. But this is like totally different paradigm, let's say, and different way of doing stuff than Elm has it. As you can see, like if we compare those two solutions, we see that the toString function on the right decides what to do with the data, where the toString on the left doesn't decide, because the data decide about, like, let's say, himself. So the data has a behavior. On the right side, the data has no behavior. This is also quite a difference between object-oriented programming and data-oriented programming or functional programming, where the data can know something or data can't know something. But that was a digression, let's say, and let's go to the subject again. So we have seen the classes approach, but we can also try to make it differently. And the way to have this kind of target union is exactly implementation of target union in TypeScript. And target union is something which has a tag. The name tag doesn't, like, it's not important that it's a tag name. The tag just needs to be some ID of the given element of this target union. And this shows us that this run one has a distance and the sleep one has no distance. And using that with switch would look like we switch over tag, and for this one, TypeScript already knows that this is a run part, because he like checks the tag by run. And here we have a sleep, and it works as expected. Still, removing this part compiler doesn't make any difference. So we have no, let's say, protection for that. We can also use, let's say, array syntax, list syntax, to implement kind of target union. This syntax is like less verbose and it has less code. So I would, like, my private opinion is that I quite like it more. But it has some downsides, like the fact that we use really array, which has a lot of methods, because this is an object which has a lot of methods there, which we really don't need to represent such thing. So outside of having a nice syntax, this has a lot of downsides. But again, also, like, this kind of using this kind of let's say tuple on top of the list makes us needs to use indexes, which, like, using indexes is always like less readable than using like names. So this can be an issue. I cannot destructure that, because when I destructuring means that I will take this object, let's say action, and I will make like I will make from it tag and argument. This is a destructuring, but I really cannot like do that. Sorry, I need to do const, because on this level I really lose the I really, if I will do the tag switch over tag, TypeScript has no idea what argument here can be. I mean, this can be, yeah, so he says it's a number, but really from the perspective of the type, it can be undefined also. So this works maybe for this simple case, but in general, TypeScript will lose information about the safety about the second argument will be lost. We can try to do like string here and see how it will go. So oh yeah, that's the good case. Even though I'm in the tag which has a run, TypeScript doesn't know that it's either string or number. I mean, he like cannot define that. Where if we don't destructure that, he is able to understand the branch. Yeah, but this is also a digression, let's say, and let's move forward. I mean, we still are not in the place to nicely replicate the right side of Elm. So we need to try better, and trying better means that we want to have protection. Protection means that I don't want to have a situation that I don't cover one of the case. So if I remove sleep now, this is a compile time error. So Typescript will not compile this code. Why? Because we did a trick using never type. And never type is like a very specific type. It's a bottom type in Typescript, and it means that never is like, we can say it's a representation of the dead code. It means that we cannot, if we have something never, it never can have a value because there is no value of this type. And in this situation, we removed a sleep option, and compiler says that we have the sleep option, which gets to this default branch, and we try to assign string, or like, let's say a list with a string inside, as never. And as said before, never represents like dead code, and this is not a dead code anymore. I mean, this default branch will be working. So the only way to cover this is to have this case. So this protects us quite well, but still the code, I mean, let's compare that, and we see that this looks scary. I mean, this looks hacky, tricky, not nice for sure. So still, let's try to make it better. And this is simple. Let's say maybe the word simple is a wrong one, but not a many lines of code here to make some type which will help us in this case. And first of all, we say sum is something which has or like only the first element, so list with one element, or list with two elements. And the first which element will represent the tag, and the second will be an argument. So our match utility type will take some value which is really a sum, and some return type. And what it does, it goes through our value first element, and our value first element is really a tag. That's why I name it tag. And this is really let's say like a for in loop. This can be understood like that, and this is really like that. So this is a for in loop where we say that let's go through all elements, all tags of our union, and if our element extends something which has two elements, so first is a tag and second is an argument, that means that we want to have a function which needs to have the argument. But if our value element only is something which has a tag, then we don't have argument, and we just have a function which has a return type. And how it works is we have an example type user, and we have example some status. And status for first available has no argument, but for taken it has argument. And if we will use our match utility, which can be considered as a function on the type level, that's how I mean, this is simple to understand when we see this as a function, because really, if we change brackets to something like that, this looks like a function. And really, it's a function, but on the type level. And when we use this function with our argument status and our argument string as a return type, in the result, Typescript will make us such a type. So our type is, you need to provide an object which has available key and string, a function from nothing to string, and taken key which has a function from the user to string. That's the result of this match. And by this match, we can create case of function which takes two arguments and returns like uses the function on the given element, which is given as our argument. And by this really code, we can try to replicate the right side. Everything is available on the GitHub. So I hope after that there will be a link to this to maybe more focus on this code. But using this utility makes us this code, like, let's say, less verbose and more safe. We have action, which is again those two elements as before, but instead of the switch, we use case of, which was just written a few lines above. And for action, which is run or sleep, we have this kind of object which replicates the pattern matching on the right side. And this object is defined by our match utility and is saying that it needs to have a run with number to string and sleep to string. If I remove that, it will be compiler error. So it protects us from without using never type. We have a full protection. There is a less code than a switch and having this default. So this is really fine in my opinion, and we are in, let's say, in the position that both sides can be considered equal. There are a little bit more syntax on the left side, but this is a language thing. Yeah, so let's try to check what Elm can do more with this. And Elm has this pattern matching made quite well, and this means that we can even do pattern matching over nested types. So this is a nested type. We have a run, and inside we have maybe. Maybe is again sum, which says there's something or there's nothing. And in Elm, we can destructure that and say run just distance, and we can say run nothing. So we can do that in the flat pattern matching. So we have nested sum type, and we can just pattern match over that. How we can do that in TypeScript? So we can emulate the maybe as just with argument or nothing. We have action which uses this maybe inside. And now by using our case of, we have the issue that the case of is not prepared to work in the way that we can have that in the one line. So we need to do that nested. So we have like case of, we have two options, run and sleep, and the next one is a case of over maybe. So for just and for nothing. So it's not a flat, but still works fine. And I'm quite happy from this solution because it's also, let's say, type safe. As you can see, works as expected. Removing this option will say that we have a problem. Removing this option will say we have a problem. Yeah, so this is really fine solution. But Elm solution is more readable because it doesn't nest itself. What we can do more is I, in my spare time, created some, let's say, type level library. It's Elm in TS. It's on GitHub, and there is a match utility which is far more, like, let's say, flexible than the original which we had seen, and it allows us for having like more flat way of pattern match. And this is an example, the same thing which we tried before, but with this match width utility, which is in this module. And now we can just do run just, run nothing, and sleep in the flat way without nesting. And even if I check what the compiler will tell me, it tells all options. So if we use run, inside we will have X maybe, but if we use run just, it's already a number inside. And if nothing, we have a function from nothing. And if sleep, so like we have also wildcard. So we can, it's kind of default. But this kind of protects us in quite nice way, and removing any option here will just shows an error. So that's really fine, and we can say that we replicated the solution on the right side. So Bunny will need to run. Bunny will need to run because we are close. And it's running, and we have more sophisticated example with a request type and action type. And the nesting is, as you can see, we have request and action inside, and action has maybe inside. So we have 3 levels deep. And this also for Elm is not a problem, because we can just destructure 3 level deep in the pattern matching syntax, and that's fine and works. For TypeScript, how we can do that, and by the utility, we can also cover that. And this is a case we say success run just. So we can nest 3 levels, and without any let's say nesting in the code blocks, and everything like removing any option will complain. If I will try to check what compiler knows, he knows a lot. I mean, he knows that we have those options, and we need to use them to cover all possible cases. So that's really what we wanted. So we have a protection that our pattern matching will cover all cases, and we will be fine with the tag, and we'll be fine with the argument, and we will be fine with the return type. So all those functions need to return the same thing, because if not, if I will return, let's say, number here, this is an error still. Yeah. So it protects for many cases. So again, like we are close to the Bunny, so Bunny needs to run and show something more sophisticated, and this more sophisticated will be pattern matching over tuple. And tuple, we have tuple example with tuple looks like we have the result type, which is defining, like we have or okay result or error result, and this is visible in the type. We have 3 elements in the tuple, 3 results, and we want to return a list of strings. And the pattern matching says, if all results are correct, then create me this list. If one of them is not correct, then create me empty list. What TypeScript can do with that? Again, I'm using the utility type. And by this utility type, we can almost do the same stuff. So we say, okay, and this is X, YZ function, and we return XYZ list. And if something different, wildcard, we return the empty list. And let's check what this compiler knows. And this looks like every permutation of possible options. It's quite nice to see that this compiler knows really what we can provide here, and will protect us from that. So this also looks solved. Yeah, so let's see what next. Yeah, next is like agreement. Let's say the dog agree with the Bunny that TypeScript can do a lot of stuff. But yeah, show me the code. Let's see, like for a moment, this utility, which I am saying that works like that. And this utility you can see on the screen, it's a mostly type level utility, and everything which you can see in the screen, I just will scroll to see that it's quite, let's say, long, and it was not so easy to write. But if you will write it, it's already there, and you just use it, and it really works nice. So the thing which was needed to create this utility are like template literal types, because TypeScript in one of the newest versions have this possibility to concatenate strings on the type level. This is really nice thing, and this is exactly how we can make this thing. Without the template literal types, we couldn't be doing that. So I really enjoy this new feature of TypeScript. This also is a Muppet type, and this Muppet type goes to the 3-level deep. I didn't make any recursive type to make a compiler fast for that. So the solution is not done. It's really a pet project. I'm not sure if I will continue that or not. I have seen that somebody already after my first presentation about this created own version of that. So I'm happy that somebody thought that it's useful. So that's great to hear. And what else? Where we can use it and why we can use it. So everywhere really, because the pattern matching and modeling the state is very important thing in programming. I will show you how we do that in React. And this is on the left side, we see a typical React component, which takes a few props, error, name, and loading. And the problem with this approach is that our props can have state which is really wrong, and the wrong state can be let's say we have a loading and we have a name and we have an error in one time. In most cases, and probably in this case, we don't have this situation and we should not have it. So we have or we have an error, or we have a name, or we have a loading. That's the real state which we should have. And this component in the code tries to fix the model. So he's saying that if we have an error, we just don't consider other options. If we have a loading, we don't consider the name, and the name is the last thing. So let's say the model of the data doesn't represent the possible states, but the code is. I mean, the code is like fixing the model of the data. So the model of the data by this model of the data, we can create wrong, let's say, application states. And by using the pattern matching, we should do that differently. And we say that this is an example with request. We have success, error, loading. And for error, we show error component. For success and just inside, we show the name. For success and nothing, we show the anonymous user. And for loading, you show the loading. So this kind of model of the state enables us to clearly define what component, what view should be representing a specific branch of our state, let's say. Yeah, as said, this library is available on GitHub. So I hope it will be in show notes after. And yeah, I think that's it. Thank you very much for that.
Super, thank you for a great presentation. And now let's check the questions. Do we have in the comment? I don't see any, but I just to remind you that after presentation and after event, you can also ask the question. You can add it in the comments, and we will answer it also in the comment under this video. And also, I would like to thank you for Maciej and for Vyacheslav. Thank you for your presentation, for your time. And thank you for all for coming for today and watching us. And also just to remind you that you have a survey form. It is very important for us, and we will be pleasant if you can fill in after the event. Okay, thank you for all and have a nice evening. See you at the next IT Talk meeting.
Thank you.
Thank you, bye.